Having functions that will add nodes for us in a doubly linked list is very easy, which is why I will simplify the add node functions and the code for those functions using some animation so that you're able to visualize, and I will also show you the code for these functions and explain it as we continue to build our linked list project. In this video, I'll show you how to add nodes to a doubly linked list, and this is the second video of the doubly linked list playlist. After this video, you will know how to add a node in front at the back of a doubly linked list, and also how to add nodes anywhere in the linked list using an index. And after I show you what the code does using some animation, I'll show you the actual code in the project files for the add node functions. I'm also about to upload the next video about printing a doubly linked list. So I strongly suggest that you click the bell next to the subscribe button so that you don't miss this video or any data structures videos and other content I would upload. And also click the subscribe button if you haven't already, and welcome to ACoreFundamentals. The goal of this video is to have three functions that will add nodes in different positions of a doubly linked list, in the front, at the back, and at an index in a doubly linked list. For example, say we want to add a node with a value of 1 in front of a doubly linked list. Our function will do that. Same if we want to add a node at the back of a doubly linked list. And finally, if we want to add a node at a certain position in the doubly linked list, which we'll call an index. And for this example, if you want to add a node of 5 at an index 3. And I'll show you how to create these functions using code. But before we dive into the code for these functions, let's revisit what we covered in the introduction to the doubly linked list video, which I will link in the video description below, along with other doubly linked list videos. So we said that a node of a doubly linked list can hold data to be stored, and the next pointer, which will point to the next node in the doubly linked list, and another node pointer, which will point to the previous node. So when creating a node using a struct, which we did, and also you can use a class, we will define an integer data variable and the next node pointer and the previous node pointer. And we then create a constructor, because every time we create a node, we want to initialize the data variable as well as the next and previous pointers, so that we don't have to do it manually in our functions. And the constructor takes in an integer value, which will be the data we want to store, and it will set it to the data variable we declared. And finally set the next and previous node pointers to null, as they are pointing to nothing for now. And that's it for the revision. For more on the introduction, you can watch the whole video. To make this simple for us, we'll create a function that will create nodes for us and return the pointer to that node itself, or where it is stored in memory. So the function has a node pointer return type. That's the node star. And create node is the name of the function. And it takes in integer data, which will be the data we want to store. Then we create a node pointer n, which will hold the location returned by the new keyword when it allocates memory for the new node with the data we want to store. And since the node construct will initialize the data variable to the data we want to store and the next and previous pointers to null, we don't have to do it manually. Finally, we return the pointer to the node, which is the pointer n, and it is equal to 1000 in this case. And we are done with the create node function. We can continue to the first add node function, which is the add front function. Adding a node to the front of a doubly linked list is very easy. Say we have a doubly linked list with 3 nodes with the values 3, 5, and 9. And we have a head node pointer pointing at the first node with the value of 3. And we want to add a node with the value of 1 to the front of a doubly linked list, meaning in front of the head node, so that the node we are adding becomes the head node. So we create our function which will add the node in the correct position. The function is a void function. We are not returning anything, and it takes in integer data, which is the data we want to store. And for this function, we only want to call another function, add front one, which is the function that will be focused on adding the node to the correct position. and this will take in the data we want to store and the head node pointer of the doubly linked list as arguments. We want to have the head node pointer that is pointing to the first node so we can access the nodes in the list. Let's look at the second function. Remember, after explaining this code, I will show you how to use it in an actual doubly linked list project. Okay, for this function, it is also a void function. It takes in integer data and the node pointer as argument. After that, we check if the head is equal to null, meaning if the doubly linked list is empty. And if that's the case, we don't have nodes in the doubly linked list, we want to set the head node pointer to the newly created node, which we'll create using the create node function as I explained a moment ago. But if we have nodes in the doubly linked list like we do in our example, we'll create a node pointer n, which will hold the newly created node, and we'll set the next pointer of the newly created node to point to the current head node, and set the current head nodes to point to the newly created node, and finally set the head node pointer to the newly created node, which then becomes the new head node. And that's it, and we have added a node in front of a doubly linked list. Now let's add a node at the back of a doubly linked list. Say we have a doubly linked list with the values of 1, 3, and 5, and we would like to add a node with the value of 9 to the back of the a doubly linked list. And as we did before, we create a function which is also a void function and takes in an integer data, which calls another function which takes in the data we want to store and also the head node pointer as arguments. We need head node pointer so that we're able to move through the doubly linked list. Let's look at the actual function. It is also a void function and takes in data and the node pointer. Firstly, we check if the doubly linked list is empty or if the head node pointer is pointing to null or nothing. And if it is empty, set the head pointer to the newly created node. But if we have nodes in our doubly linked list like we do in this example, we want to create a while loop that will check if the current node's next pointer is pointing to null, because the node whose next pointer is null is the last node. And since we passed in the head node pointer as argument to this function, then the node pointer ptr is also pointing to the head node. So in our while loop, if the pointer ptr or the current node's next pointer is not null, we want to advance the pointer ptr to point at the following node with the value of 3. And if the second node's next pointer is not null, we advance the pointer ptr to the following node with the value of 5. And this node's next pointer is null, so we exit the while loop. And the pointer ptr is still pointing to the node 5. And so we set its next pointer to point to the newly created node. And then we set the previous pointer of the newly created node to point at the node pointer ptr is pointing at. And it's that simple. And before I show you the complete code in the project files, let's look at the function. And if you're enjoying or getting value from this video so far, like this video down below. Okay, say we have a doubly linked list with the values 1, 5, 9, and we want to add a node with the value of 3 in the second position or index, or after the first node. We'll create a function which is a void function, and this only takes in 2 arguments: the index or position where you want to add the node and the data you want to store. And it calls another function which takes in the 2 previous arguments and also the head node pointer as the third. Now the second function, which takes in an integer index value, the integer data value, and a node pointer. We first create a node pointer C and define an integer counter X, which will help us in keeping track of the positions. And we set it equal to 1 because the first node is at position 1, which is where we will start. Now since we passed in the head node pointer as argument and set it equal to ptr, therefore ptr is also pointing at the first node. For us to find the position to add the node, we create a while loop which will check if we have reached the position we want, and if not, keep running until we find that position. So if x is currently pointing to 1 and is not equal to the index, which in our case is 2, we enter the while loop and we set the pointer c to point where ptr is pointing. The reason we do this is that we want to leave the pointer c one step behind ptr so that we have access to the previous node. We then increment the counter x by 1 and advance the pointer ptr to point at the following node, which has the value of 5. Now x is equal to 2, and since x is equal to 2, same as our index, we exit the while loop and create our node. With the node pointer n pointing to the newly created node and the pointer c pointing at the node with the value of 1, so we can access its next pointer and point it to the newly created node n. And you can point the previous node pointer of the newly created node to point at c. Then we want to point the next pointer of the newly created node to point at ptr. Finally, we want to point the previous node of the node ptr is pointing at to point at the newly created node. Finally, point the previous pointer of the node ptr is pointing at to the newly created node. And we are done, having the resulting linked list with the node 3 added at an index 2 or position 2. Now let's look at how all of this works inside the project files we created for the Doubly Linked List project. We'll continue with the project we set up in the previous video, which was the introduction to the Doubly Linked List, and we'll create the function prototypes for the add node functions. The first function I want to create is the function that will add a node at the front of a Doubly Linked List. Now this will be a void function, and I will call it add front. This function only takes in one argument, which is the data we want to store, and then we'll continue to define the function prototype for the next function, which will add a node to the back of a Doubly Linked List, and we'll call it add back, and it also takes in the data we want to store. Finally, we want to add a function which will add a node at a certain position, and this function takes in an index, which will be that position, and the data we want to store. Now inside the private section of the class, we want to create the second functions, which will be the add front 1, which takes in the data and the node pointer, and add back 1, which also takes in the data and the node pointer, and finally another void function, an add node 1 function, which takes in an index, a data, and a node pointer. That should be add node 1. Now going to the doublylinkedlist.ccp file, we will actually define this function. Now for the first function, the add front function, which is from the add front function. This function takes in data and will only call the add front 1 function. This function will take in data and the head node pointer. Now the add front 1 function, which is from the doublylinkedlist.h file, takes in the integer data and the node pointer. Now inside this function, the first thing we want to do inside the if statement is that we want to wait. I just remembered that we forgot to create a function that will create the nodes for us and return the node pointer and return a node pointer to that newly created node. So it has a node pointer return type. But first we need to create its function prototype in the header file. So create node, and it takes in integer data. Okay, now back to the doublylinks.ccp file. This function will only take in integer data. So we want to create a node pointer that will hold the newly created node that will store the data, and we just want to return that pointer n. Okay, now back to the add front one. We want to check if the doubly linked list is empty or not, and if it is, set the head pointer to the newly created node. That's it. But if we have nodes in the doubly linked list, we want to create a node pointer n, which will hold the node we are creating, and then we want to set its next pointer to point to the current head node pointer, which will be ptr, and we want to set ptr, the previous pointer of that node, to point it to the newly created node. And finally just set the head node pointer to that newly created node. And for adding a node at the back of a doubly linked list, we'll call add back, and this one takes in the data we want to store and only just calls add back 1 and passing in data and head node pointer. Now defining add back 1, which takes in integer data and a node pointer. Now we want to check if head is equal to null, and if it is, that means then the list is empty. We want to set the head node pointer equal to the node we're creating. But if we have nodes in the list, we want to set ptr, and we want to check if ptr next is not equal to null, and while that's true, we want to advance the pointer ptr to point to the next node. And when we finally find the last node, we want to point n to that newly created node, and we want to set the previous node's next pointer to point to the newly created node, and we want to set the previous pointer of n to point to the ptr, Now adding a node at an index, we will define the function addNode. This function takes in data and calls addNode1. This function takes in an integer index value and the date, so we'll pass in that index and the data along with the head node pointer to addNode1. Now let's define addNode1. This function takes in an integer index value and an integer data and a node pointer. The first thing we want to do is to create a pointer c and an integer counter variable and set it equal to 1, which will be x. And we want to check if the head node pointer, and we want to check if the index is not equal, we want to check if the index is less than 1 or if the index is greater than the size of the linked list plus of the doubly linked list plus 1. I forgot to we need to initialize the size to 0 when an instance of a doubly linked list is created. We also need to declare the size variable. Okay, because we need to keep track of the size of the doubly linked list as we add nodes to the doubly linked list. So we need to increment the size variable every time we add a node. Okay, so if the index is outside this range, we want to output invalid index. But if the index is valid, we will create a while loop that will check if we have reached the index we are looking for, and if not, we will create a pointer c, set it equal to ptr, increment the counter x, and advance ptr to the next pointer. And when we find our index, we want to create a node, and then we want to point c's next pointer to n, and then we want to point n's previous pointer to c, and we want to point n's next pointer to ptr, and increment the size of the doubly linked list. And I think that's it. So now we'll go to the main.ccp file, get rid of this, and we want to see out adding nodes to the doubly linked list. So we will call these functions. First, we will need to create an instance of a doubly linked list, and I will call it my doubly linked list, my doubly linked list. So we will call add node to back, and we'll add 3. So we want to call it a few times, and add 5 and 7, but this time and also add 9. And now I want to add a node to the front with the value of 1, and finally add a node at an index. We'll add a node at index 3, and it has the value of 6. Now let's compile the code to see if we have any errors. And looks like we don't. So we need to run the executable file. And yeah, we've added everything. And now that we know how to add nodes to a doubly linked list and have a solid idea of how they work, we can now move on to discuss printing nodes from a doubly linked list, and I'll be discussing the print function so we can see our doubly linked list. And please take only just 10 seconds to click the subscribe button, because it helps me to grow this channel, and while you're there, just turn on notifications so you don't miss any videos that might help you in the near future. Thanks for staying with me until now. You can support me by checking out my Patreon page. I will leave the link in the description, and welcome to ACoreFundamentals.